In this lecture, we will learn about experiment problems and we will find the maximum or minimum points by using the second derivative test. In the previous lecture, we have learned how to find the local maximum or minimum by using the first derivative test. So what's the difference between the first derivative test and also the second derivative test? Well, the first derivative test simply means that we have to differentiate once. So it's dy over dx only. But for the second derivative test, this means we have to differentiate 2 times. And how to use it? Let me explain. Now, for this method, we know that we have to evaluate the second derivative test at the stationary point. So this means we have to do the same method as in the first derivative test, which is finding the stationary point. So how to find the stationary point? It's just dy over dx equal to 0. Find your value of x, find your stationary points. After that, substitute your value of stationary points into your second derivative test. After you have substituted your values, you will get a number. If the number is greater than 0, then it means that the point is a local minimum point. How to memorize this? It's simple. When it's greater than 0, remember that you are smiling because it's greater than 0. So it's like you have a lot of money, so you're smiling. And when you're smiling, you see that it's actually a minimum point. So remember that when it's greater than 0, that means you have a lot of money. So you are smiling. So when you're smiling, there's a minimum point. Next, if it's less than 0, so this means you have not enough money. So you're sad. When you're sad, you have that sad face, and that's a maximum point. And one more is when it's equal to 0. So when the second derivative is equal to 0, this means that the test is failed, because you want to know whether it's a local minimum point or local maximum point. But when it is equal to 0, then the test fails because it's not a minimum or maximum point. And how are we going to make sure that it's not a maximum point or a minimum point? We have to do the first derivative test. So you have to do that box again of that first derivative test with the stationary points inside it. You must also do the first derivative test if f prime does not exist. Remember, when you get these two conditions, you have to do the first derivative test, which is the table that you have learned in the previous lectures. Now, let's look at example 1. Given that fx is equal to this function, find the maximum and minimum points by using the second derivative test. So in this question, it has mentioned clearly that we have to use the second derivative test, so we cannot use the first derivative test. The same method applies. To use the second derivative test, you still have to find the stationary point. And how to find the stationary point? The first step is always the same, which is differentiate and equate it to 0. So now we have the function f. We have to find f prime, differentiate it, and you get negative 3x squared plus 18x minus 15. Equate this to 0. Before you press your calculator, see whether you can simplify this equation. So you can divide everything with negative 3. After you have divided everything with negative 3, you get x squared minus 6x plus 5. Now press your calculator and you get x minus 1 times x minus 5. Well, what happens if you simply press your calculator straight away before writing this step? What will happen is you will get x minus 1 times x minus 5. But after you expand this, you will not get negative 3x squared plus 18x minus 15. So if you do this in the exams, you might lose marks because your factorization is not the same as the original equation. So that's why whenever you get this type of question, what you have to do is simplify or make sure that you have the same answer. So if you don't write this step, make sure you write a negative 3 in front so that it's equal to the original question. But if you don't want to do that, you can also simply just divide everything with negative 3, simplify it first before you factorize and press your calculator to get these two values. Because after you expand these two factors, you will get the one that you have simplified. Now, your stationary point would be x equal to 1 and x equal to 5. Remember, it's a point. So when it's a point, we have the coordinate. We need to know what is the value of x and also what's the value of y. So we have found the value of x for the stationary point. find the y, just substitute in the x into the original equation y or fx. So substitute in your 1 into that fx function, and you find y is equal to 4 when x is equal to 1, and when x is equal to 5, your y is 36. So your station points would be with its partners 1 and 4, 5 and 36. So we want to determine whether these 2 points are maximum or minimum points. So for the second derivative test, what you have to do next is to differentiate the dy over dx that you have obtained before. Negative 3x squared plus 18x minus 15. You have to differentiate this one more time for the second derivative test, and what you get is negative 6x plus 18. Now write it here. After that, substitute your values of stationary points. The first stationary point is 1, 4. So at 1, 4, substitute your value of x equal to 1 into this second derivative test. But if there is a y here, you need to also substitute your y value into the second order differentiation. But for this question, there's none, so you don't have to substitute in the value of y. Just substitute in the value of x of that stationary point. And your answer is 12. Is 12 greater than 0 or less than 0? It is greater than 0. Are we smiling because we have a positive amount of money in our account? Or are we sad because we have negative amount of money in our account? Well, we are smiling because it's positive and there's a minimum point there. So that's why 1, 4 is a minimum point. What about at 536? You cannot assume that when one point is minimum, the other one must be maximum. It doesn't work that way. We have to check. So substitute in your value of x, 5, into that second order differentiation. After that, you get a negative value, which is negative 12. When it's negative, remember, it's like you are having a negative amount of money in your account. Are you happy or are you sad? Of course, you are sad. When you're sad, you see that there's a maximum point there. So at 536, it's a maximum point. So for this question, you have 1, 4 is a minimum point and 536 is a maximum point. Please write your conclusion clearly. Now, you can also have in the same question, both are maximum points or both are minimum points, or an inflection point. For example, in example 4, let me show you. Try out example 2 and 3. In example 4, we have this function. We like to find the local maximum and minimum. First step is the same. To find the local maximum and minimum, of course, we have to know what are the coordinates for that point. And to find the stationary points, we have to differentiate and equate it to 0. So differentiate it first, equate this to 0, and how to factorize this. This is x power 5, x power 4, and x power 3. You can factorize x power 3 outside and bracket x minus 10. Make sure you write x power 3 outside, because if you simply press your calculator, of course you get only x equal to 0 and x equal to 10. So that does not mean that we have this factorization is wrong, or like this. It's wrong, because if you expand this, you get only x squared, but now we have x power 5, so be careful. It must be x power 3 outside. Make sure when you expand this, you get exactly the same equation as before. If not, then your marks will be deducted. Now, next, we have find our value of x, so we need to find the coordinate. After we have found the x, you need to find the y, and how to find the value of y, just substitute the x value into the function f. So when x is 0, you get y is 0, and when x is 10, you get y is 50,000 over 3. Write them in coordinate points. So when x 0, y 0, it's 0, 0, the origin, and when x is 10, y is 50,000 over 3. Next, we have to solve it by using the second derivative test. So just differentiate this. First derivative once again. So when you differentiate this, what you get is bring 5 to the front, 5x power 4, and then 4 times with 20, you get negative 80, x power 3, bring 3 to the front, you get 300x squared. Need to do after that, remember your steps. So the steps would be, the first step is to find the first derivative, equate it to 0 because we want to find the stationary points. Remember, it's a point, so you have to write them in the coordinate forms. Find your value of x and your value of y. Second step is to find the second order of differentiation. After that, substitute your value of coordinates into this second derivative. Once you get it greater than 0, what you have to do is the smiling face, so this is a minimum point. When the answer is less than 0, you have this sad face, so it's a maximum point. And when it's equal to 0, this means the test fails. You have to do the first derivative test to check the type of point at that coordinate. Now, we have reached the second step. After you have differentiated, substitute the coordinate inside. When you substitute your coordinates inside, what you get is the value 0. So this is equal to 0. Remember what you have to do next? It's the first derivative test. Next, substitute the second point, and the value that you obtain is also equal to 0. So for the second coordinate as well, we have to check by using the first derivative test. Evaluate dy over dx on both sides of x equal to 0 and x equal to 10. So you have to remember the steps for the first derivative test, that table in the previous lecture. Now, once you have found the stationary points, what you have to do next is that table. So write your number line. Imagine that this is your number line of x. Start with the smallest number and then followed by the larger number. And then add 2 more and stretch the lines. Stretch the lines until you get a table. These columns would be for the numbers, so we need to add 1 more column for the subject of each rows. After you add 1 more column, at the end, write your rows. We must have 3 rows. Extend your lines. Make sure you have 3 rows. Remember, your first row would be the values of x. The second row will be the value of dy over dx. And the last one would be the slope or tangent. So the values of x is here would be the number between negative infinity until 0. So it's any number less than 0. You can choose, for example, negative 1. And here is a number between 0 and 10. You can choose any number, but I would choose 1 because that's the easiest number. Next, the last column would be any number greater than 10. You can choose any number, but I would like to choose 11. Next, the value of dy over dx. We want to check whether it is positive or negative. When we substitute these values inside, dy over dx, we have obtained it previously. Now, just substitute in negative 1 value into your dy dx. Substitute negative 1 into the x of this first derivative, and you find that the sign is negative. So just write negative there. Next, substitute in value of 1 into this dy dx, and you get a positive sign. Next, substitute the number 11 inside this dy dx, and you get the answer is positive. After that, remember your slopes. It's either going up or going down. So when the value of dy dx is negative, it means that slope is going down. Next, it's positive. So that means the slope is going up. And the next one is also positive. So the slope is going up. Now, next, add 1 more line in the middle so that it's easier for you to see what type of points this is. So add the line here so that you can connect these 2 lines together. And you see that exactly at this point, which is 0, your coordinate 0, 0 is a minimum point. So write your conclusion. Coordinate 0, 0 is a minimum point. Next, we have a line going up and also going up. So to connect these two lines at the end here and also at the end, to connect these two lines, add one more line in the middle. So as you can see, it's not a maximum or minimum point. So what is the shape of that line actually is? It actually looks like this, like x power 3 graph. So this is an inflection point. It's not a minimum or maximum point. But the question now is currently asking about finding local maximum and minimum point. But at the coordinate 10, x equal to 10, here we found that it's not a minimum or not a maximum point, but it's an inflection point. So we don't have to write that answer. Only 0, 0 is a minimum point. But if the question wants to know or wants to determine the nature of the points, then we should mention that the coordinate 10, 50,000 over 3, this coordinate, is an inflection point. So you can just leave your answer like that. Now try out example 5 and also the examples in lecture 4. Thank you for watching.